Good morning, children. Today we are going to study one problem which is out of the textbook but definitely well within the syllabus. The figure is there on the board. It is given that line L is parallel to side BC. It is intersecting the sides in points M and P as shown, and we have to show that Mn upon Np is equal to Bc upon Cd. The proof is very simple. You can very easily understand the proof. Line L is parallel to side BC. This line is parallel to this side. Okay? Therefore, this angle will be congruent to this angle. Angle AMN will be congruent to angle ABC. We have written AMN is congruent to ABC. The reason is corresponding angles. But there is one more pair. This angle is also congruent to this angle because these two angles are also corresponding angles. So we have written ANM is congruent to ACB. For both the statements, the reason is same. We have given number 1 to these two statements, combinedly number 1. Now we are going to use the congruence of these two triangles to prove that the triangles are similar. Congruence of angles. Okay. In a triangle AMN and triangle ABC, in triangle AMN and triangle ABC, these two angles are congruent. That means these two statements are copied here. AMN is congruent to ABC, ANM is congruent to ACB, because we have already proven that these two angles are congruent because these are corresponding angles. So we are using that information here. Now two pairs of angles are congruent. Therefore, these two triangles AMN and ABC are similar by AA test. They are similar by AA test. We know that when we are writing the similarity, we have to maintain the 1-1 correspondence. But in this example, it is very simple and very clean and clear. So, triangle AMN and triangle ABC, they are similar. So, we have written that they are similar. But we know that when the triangles are similar, corresponding sides are proportional. Okay, so I wrote Mn upon BC is equal to AN upon AC. AN upon AC. Now, there should be a simple logical question that, sir, why not third ratio is also written? Now, for that you have to do a bit of research in your figure, that these two triangles are similar. In the same manner, these two will also be similar, which we have written. And there is the middle segment which will link the triangles on both sides. So this is the segment AC. You can name it in a 3-letter name also, ANC. This is the segment which is going to link the triangles on the left side with the triangles on the right side. So that linking factor, which is also called as middle term in logic, okay, that linking factor should be used in order to connect the left side with the right side. So that is what I have done. Okay, Mn upon BC. Why did I take Mn upon BC? I need Mn and BC in the required answer. Okay, so whichever segments are required in the answer, those should be used. So I wrote Mn upon BC is equal to AN upon AC. And I told you, why did I take AN upon AC? Because AN upon AC is going to link the information of the left side with the information of the right side. Okay. Now, again, we have written line L is parallel to side BD, side BC or line BD also you can say. We have written side BD. Okay. Now, In these two triangles also, this angle will be congruent to this angle. Angle ANP, here we have written, angle ANP is congruent to angle ACD. ANP is congruent to angle ACD. And this angle will be congruent to this angle. These two angles will be congruent because these are also corresponding angles we have written. So whatever is the logic on the left side, 100% same is the logic on the other side also. So this angle is congruent to this angle. This angle is congruent to this angle. These angles are corresponding angles. They are congruent. And again we are using this to prove that the triangles on the right side of the segment, they are also similar. So I am taking triangle ANP and triangle ACD. ANP and ACD. These two angles are congruent. We have written here. ANP is congruent to ACD. Then APN is congruent to ADC, which we have already proven in statement 3. Therefore, I have given the reason. From where did you get this? From statement 3 or from equation 3. And therefore, again, these two triangles will be similar by AA test, because two pairs of angles are similar. Therefore, the triangles will be similar. Now, these triangles are similar. Again, I am going to use the linking segment. This segment. So, I will write AN upon AC. AN upon AC is equal to NP upon CD, which I can write AP upon AD also. But why am I not writing? For that, you have to use your common sense that these segments are not required in the answer. So, there is no point in writing that the third ratio is also equal. Though we get the information. In all previous lectures, I have been telling you this, that you get a lot of conclusions from certain statement which you have derived. But all those conclusions are not needed in the future course of the solution. So why should we use that information which is not required? Okay. So therefore, the third ratio we have not taken. So AN upon AC, AN upon AC, this is equal to NP upon CD. Okay. Now if we observe equation number 2 and equation number 4, we observe that the left hand sides are equal. Rather, we kept them equal. That is our plan of line of action. That this is the linking factor. So this ratio is equal to AN upon AC, and AN upon AC is equal to NP upon CD. So it is just like A is equal to B and B is equal to C. Therefore, A is equal to C. So we have written, therefore, from equation 2 and from equation 4, Mn upon Bc is equal to Np upon Cd. This ratio is equal to this one, and this one is equal to this one. That means the first ratio is equal to the last ratio. So we have obtained that result. But that is not the required result. That is not the required result. Observe the required result. Mn upon Np is equal to Bc upon Cd. So what I needed, that Np should go to this side and Bc should go to this side, which we can very easily do using alternando. So I have interchanged the positions of these two terms, and finally I have got this result. Mn upon Np is equal to Bc upon Cd by alternando, hence proved.